Okay, here we'll consider the while loop structure. The graphics for the structure suggest this notion of repeating something until a certain condition becomes true. So it's like wrapping your block diagram with the arrow. We have the loop iteration available, and then we have the loop condition that indicates how we determine when to stop executing this loop. We can choose either stop if true or continue if true. So that affords some flexibility. Well, to work with this a bit, let's attach an indicator to the loop iteration terminal. And I'll create the default control, which will be the stop button. Let's just try running and see what happens. Wow, okay, so the iterator shows that it's able to execute many times. Let's try slowing this down a bit so we can see it. "250 milliseconds will give us a quarter of a second between each loop iteration. One thing that I like to do to the stop button that's pretty quick, under key navigation, we can associate the stop button with the escape key. And that way when you're running, you can do a Control R to start and then escape to stop. Let's add a little bit of contents inside the while loop. So I'm going to add the current iterator value to a value from outside the loop. And typically I would do a right click and then create a control, but that's not available to us here. So let's place our own numeric control. I'll call that A. I'll move that to before the loop execution itself. The little orange square that appears is called a loop tunnel. There's another loop tunnel. You can create an indicator here. I'll call that Y. And I readjusted my front panel just a little bit there. So I'll try putting in a value for A. I'm going to lengthen the delay to 1 second so we can concentrate on what's happening. Okay, here we see indication that we've got some activity inside the loop. We don't see anything appearing on the output as of yet. We stop the loop, and then we see whatever was the most recent calculation inside the loop appearing at Y. All previous values had been discarded, essentially. Just the most recent value appears. Let's try highlighting execution again. And again, what we see is a little bit of activity inside the while loop, and when it terminates, then the value from the loop appears at the output tunnel of the while loop. I'm going to enable auto indexing, and what's happening here is the broken arrow, or sorry, the broken wire is telling us that we're trying to attach a 1D array to a scalar indicator. So I'll delete my indicator, create a new one. And now we can observe the effect of indexing. Now what happens is that each value, or the value on each iteration, is preserved, and then whenever the loop terminates, all of those values are presented in the form of a one-dimensional array. And I think if you study those values, you'll see that they do in fact make sense. Another technique is to replace the tunnels with shift registers. Now in this case, again, we're seeing the broken wire indicator, and that's telling us that now the while loop is generating a scalar output instead of an array. Let's again create a new indicator for that. And let's try running and watch what happens. Now with this method, the shift register on the right side basically passes its values back to the shift register terminal on the left side, and those values keep getting updated as the loop progresses. So the value of A is simply a way of initializing the value. Again, it might be worth pausing and replaying this video a little bit and kind of concentrating on the flow of information that you see here. Again, here you can see evidence that the previous calculation shows up at the right side shift register. All right, and that's the basics of the while loop.